I'm here to talk about one common issue that we see when we configure an object address for within FQDN, and sometimes that particular security policy does not match. So this is the illustration of that behavior. And just before we start, I just want to uh, let you guys know that this is an expected behavior. Uh, this is this has nothing to do with the configuration on the firewall or the client. It is basically how the DNS works and how its caching works. And sometimes this could cause an issue when there is a shorter TTL with the IP address, that is frequently changes on any record, DNS record. So in this case, I am taking this AWS Amazon.com because I noticed this FQDN changes very often. So just to quickly show you the config, this is added in one of the policies here, which I am using to match a security access rule. I have named it as access to AWS, and this policy is pretty straightforward. It just have that FQDN object aws.amazon.com here, and and it's allowed. And I have created another security policy and have added like manual IP addresses here. These are the 4 IP address I could see they change, and I have used it as deny just to demonstrate that sometime the traffic would hit this policy, but when there is a difference of the client cache, when the client caches a certain IP address which does not match on the firewall, it will fall into number 4 policy. But if both are same, then it will use this. Uh, or I should say, basically, whenever, I mean, it's the firewall, yeah, value, that has to match with what client is trying to connect to, and that's when this policy would hit. So just a quick summary of this feature, right? So my current setting is set to FQDN refresh timer is set to 0. What that means is the firewall will refresh the FQDN based on the TTL value of the DNS record. So it will ignore the FQDN refresh timer. So just a quick overview of this feature. Whenever we have, let's say you have a 30-second, which is the by default minimum FQDN refresh, and the file and the A record for that for any FQDN is, let's say, 10 seconds, right? If it is less than the configured value, which is 30 is greater than 10, in that case firewall is going to use the FQDN refresh timer. But if it is smaller, then it will use the TTL of that particular host. So this is what it says, right? The firewall refresh the FQN based on TTL as long as it is greater than minimum. So if it is greater, if it is 40 seconds, then it will use the TTL. But if it is less than that, so in this case, sorry, it is 10 seconds, then it will still use 30 seconds for that refresh timer, right? So firewall would hold that value for 30 seconds. But if the uh, client is caching it only for 10 seconds, then there could be an issue. And that's what I'm going to demonstrate here. So let's take a look here. I did push this config. Okay, so this is my client. So I'm going to check what is the DNS value or the A record for this. You can see it was earlier 65.13 one time, 65.8 this IP. So the current value is 65.8. That is the A record. So if I were to start ping to AWS uh, .amazon.com, it is going to use 65 as the IP address, and we can see we are hitting the issue already, that it is going to the number 4 policy. Now let's take a look at the client side, right? So what is the firewall using right now? So firewall value right now is 18. Why it is 18? Because if you look at uh, the show DNS proxy FQDN, it has this value 18. It is going to use that until the cache expires, right? So right now the client has a different cache. That's why it is using 65. Uh, and since the 65, it does not match on the firewall, it is going to show as the deny. So let's take a look here. You can see in the security policy. So this is like from my testing, you can see one time it was hitting this and another time it was hitting this. But now we have changed it to, okay, let's filter with ping. We can also check the, uh, yeah, so here is the deny rule. So you can see it's 65, and it is hitting this number 4 policy which we have. Because I have added that IP address here. Uh, and I'll demonstrate once these two values on both the sides. So this it's hitting this because it has 65 is added here and it is deny, right? So all these IP addresses are actually the IP address of this aws.amazon, right? So I have added this just to demonstrate that when the values of the client DNS cache and the firewall they do not match, then it is going to hit that number 4 policy. So let's see if that is changed. It's still using, I think, okay, it's still using 65. So it's 65 right now, and let's see what firewall is using. Okay, it is still 80. So let's wait for it to actually change. Uh, it should change once that cache expires and it gets a new IP. And once that happens, it will start using it. It should, use the correct policy, which is number 3, uh, which has the FQDN listed on it. Uh, okay, I'm going to check what's my client. Okay, so it's using public IP 8888. Okay, and my client, my firewall, I believe is using, that is one of the IP address, but the primary IP address is 999. So I'm going to use that here to dig at 99 aws.amazon.com. Okay, so now I think I'll have the uh, so now I'll have the basically. So the issue was because we are pinging. I'm trying to get the same value or ping a DNS server, query a DNS server, two different DNS server. So if they are different, then the answers could be different. Okay, so but in reality, it is using that. So let me change my DNS server real quick to a 999. That way, client is going to use uh, okay, 9.9.9.9. So this will make sure my client is also querying the same DNS server as the firewall. Uh, and hopefully that will trigger a same, yeah, now it's 18, ping AWS. Okay, now it's, okay. All right, finally we are able to see now it's pinging and the firewall should have the same value as 13, yeah. So now it has the same value and we can see that the traffic is going through. So if we check source session all, filter, destination, and we check the session table and the ID, it will show us the correct security policy. And it is working now because, okay, great. So now we can see it actually stopped working, probably because the value on the firewall changed already. Uh, so yeah, you can see it's 18 here, and the client was also, was pinging 13. So you can see how, it's not actually even intermittent, it's pretty frequent. You can see that. And if you were to take this IP address and let me stop this. If you were to take this IP address and check the logs on the firewall, we would be able to see that uh, the traffic is going from one security policy to the another. So let's take a look. Let's filter this. So this is the IP address from the client. So here you can see that when the cache on the firewall and the client was matching, it was using this security policy access to AWS. When it was not, then it switched to this no AWS access URL filtering, which is basically a deny. And the reason being the values of what firewall has for that particular FQDN is not matching with the client because of its shorter TTL and frequently changing IP address. So that's why, again, this is not a issue with the firewall configuration. It's or the client. It's basically how DNS behaves, right? So DNS client actually caches the TTL, any A record query, and use that for its TTL value, and it is not going to change it. And same thing happens on the firewall, because firewall is also acting as a DNS client in this case, and it gets the A record, it caches for a certain time, and then it is going to happen that the what client has and the firewall has, they at sometimes they are not going to match, and when that happens, it will not match the security policy. So to basically work around, or to have a workaround, or you could say resolve this issue, uh, we should use URL filtering or EDL, so that we are not dependent on the cache itself. Now, the shorter TTL itself is not the issue. It's just the changing of the IP address that is the issue. Hopefully, this was informative. That's all from now. Thank you.